Hello, let's continue. From the previous video, we had a bug with collisions. Okay, let's edit that. There were problems with the collisions of certain elements. With the new logic of the partial stickiness. Let me check. Let's load another level to test. The problem was this. Okay. Boxes that are not sticky pass through each other. Okay. Let me see. I think the problem was in this function. Yes. Yes, because we are checking. Okay. What's specifically the problem here? When falling, for example, the boxes, the falling logic is a kind of push, a push downwards. And also there was, I think, there was this same problem if I push. Okay, yeah, the problem is when we check who is pushing who, we must check. Let's make, this is too long. Let's make an auxiliary function. Stick check, or what's a better name? Or stack. To grades, let's return a small. Okay, we must check first we must check, of course, if they are together, and then the stickiness. Okay, let's this direction is a vector. It's a vector integer. If the two boxes are not next to each other, return false. And now we must check in the direction this was a list, no? Okay, yeah, this is a list or an array. In Godot, arrays are really lists, but I don't know what is the internal representation. but they are quite efficient. And this is the other direction. Okay, if A is sticky in this direction, or B is sticky in this other direction. Okay, I could return, instead of doing this, I could return directly this. Let's check if this works. Okay, these two are sticky. These two also are sticky. Let's check. These two are not. Okay. Good. And now we must check not only if we are stuck, yeah. If the neighbor is in the same direction as the move, no, it's an or. Let's check this. Okay, this. Okay, I cannot push. Let's check another situation. Perfect. These two are stuck, but these two, no. Okay. I think that will be enough. No? Let's check if I can. Here I'm pressing down. I should be able to grab this box, but I cannot. Why is that? Let's check the move logic. If we are moving down and we are not holding anything, region forms. This is the crate we are grabbing. Here it is. Here I'm checking if there is a box below the crate I am grabbing. So let's take that crate and check if the two crates are stuck. Because only if they are stuck, we must return false. I think. Let's check that. For example, this is perfect. Oh, but I cannot. Good. It's working. Perfect. And if we let's check another situation. These two now are stuck and perfect. It doesn't let me grab. Okay. This is working. I think. I can grab this. Nice. Now, what must... Well, of course, this logic must transcribe this logic into the generator, and generate proper levels with this stickiness. Let's check the differences. Layer. Okay. Create below. Okay. Let's open the generator. I should show I was preparing some time ago these members of the struct crate to hold the information, but I'm not using them anywhere. Sticks to... This is not used. Okay, sticks to... This I should rename, because I'm making these videos in English, so perhaps I should rename all the identifiers to English, but I don't know. I don't know. I will do it incrementally. Rotate. Let's check if I broke anything. Okay. Let's try to use sticks to. This function is not very useful, I think, because let me check, the function I added is rstack. It takes two crates and returns a boolean. So let's port that logic first below the move logic. So this will be indexes instead of crates, I think, because I use yeah. let's use indexes. Because each puzzle has an entry point, a player position, a set of spaces, a set of crates, a list of crates. Okay. So we'll make, I have, yeah, this function. Okay. It's a bit zen to port code from a system to another. Okay. Now this is tricky, because if I use these booleans, yeah, I'm doing these sticky directions. I use an auxiliary function for that. I should use this one because this is the official. Let me check. Let's use I think what happens? What's the problem here? Okay, if I do this, this should be stick L. This function is not used. This is solved. Incompatible types. 607. What? Because crates have the position. Okay, this is correct. Now, to use this, I must, in the constructor of the problem, I must let me check where I add the boxes here. non-crates. Let me use the debug version so it's more. I don't have. No worry. It's not so fast, so much faster. Okay, in the generator, I crates. Okay, here I'm creating a crate. Let's separate the variable. Let's do this, for example. Is this correct? If I add this one, now all the crates are sticky to the left and the right. Now I must change two functions. This one, let me check now. This is okay. I must use this condition. Another Spanish word. Let's use the name, the same names of there, or stuck. Nice. And where else? Functions, the condition, here in try move or in move, we have to check the crate below. So move plus there. If are stuck, I think that's all the changes for the logic. Okay, let's do properly the random directions. This is not needed, but this by default. E is a very nice language in that all variables are initialized to 0, or, well, if they are float, they are initialized to not a number. And the arrays are empty by default at start. So I don't need to do this, but here I'm checking randomly the 4 directions. Why is the go back? This is not working. Remove. Alt left. I go forward. Okay. Perfect. Here I'm checking the 4 directions. This should be called move directions. I don't know. And randomly add the sticky info. So let me check. This let me check. Rotate. I change this to a list. Okay, that means I don't need this feature of the compiler anymore. I thought the use of bit fields would be faster, but D is already a fast compiled language. Okay, the only issue here is the representation of the levels, because the levels are represented in this format. We have a very visual format. If you check out the first level, this is the representation. The O symbols are boxes or crates. The hashtag symbols, I don't know how they are called. The hashtag symbols are walls, and the equal signals and symbols are the exits. And each solution is represented with the same symbols, but in the positions. For example, this solution, obviously the solution is not working because I changed the logic, but the solution has the boxes in this position, and this is the solution, the signature, etc., and other statistics. This other solution has the boxes in this position, etc. The problem I have now, and I think I will left it as a cliffhanger for the next video, is how to represent the stickiness in the level format, because obviously the crates are no longer always sticky, and they must have the levels must have, or rather the level data must have the information about which sides of the boxes or crates are sticky. So I think I will left it as an exercise or as a cliffhanger. Obviously it's an exercise for me, not for the viewer. But as a cliffhanger, I will left it for the next video. Thanks for watching. Bye.